Okay, guys, so let's start. So last time I explained if you have a function with three variables, how can you simplify this function using mix? Okay. So as I told you, if you have three variables, you should have 2 to the power of 3, which is eight different cases. And for every case, we have min terms. So in total, you can have up to 8 min terms. That's why we had here 8 squares. Okay. So today, I'm going to explain how can you do the same thing, but for functions with four variables. You will find there are a lot of similarities between 3 variables and 4 variables. Also, you will see some differences. So here, in case of 4 variables, okay, so how many different cases here you have? How many inputs you can have? Okay, so 2 to the power of 4, which is 16. So you can have different, that means you can have up to 16 main terms, as you see here. Okay, that means our map should have 16 squares. Okay, that's why you can see here in this map we have 16 squares. For this map here, as you see, this is if you have 4 variables, and the 4 variables are W, X, Y, Z. The order here is very important. So W here, this is the most significant bit. Okay? Order is important. W, X, Y, Z. So if this is the case, so actually this is the area of W. Here, this is the area of W. What it means? It means if you see all the midterms here, they have W. All of them have W because this is the area of W. And when I tell you this is the area of W, that means anything else is the area of W prime. Okay? So if you look here, all these terms have W prime. Okay? This is for W, which is the most significant bit. The next bit, we call it X. As you see here in this figure, this is the area of X. Again, all terms here have X. Okay? Any other areas, like these two areas here, are actually X prime. You can see X prime here and X prime here. Okay? This is for the second one. So I'm taking it left to right, this way. Okay, what about Y? So this is the area of Y. So here, again, you can see all terms here have Y. All of them have Y here. So that means this is Y prime. So you can see as well here, you can see Y prime. Okay? The last one here is actually Z. So Z is actually here. This area is Z. Okay, thanks. So this is the area of Z here. Okay, so again, you can see all these terms have Z. That means this area and this area are actually Z prime. So Z prime is these two areas. Is that okay? Okay, so again, I'm gonna say it again, guys. So for example, if I change this one instead of W, X, Y, Z, for example, I'm gonna call it A, B, C, D. Again, whatever you have here is actually should be here, W. Okay, A or B or C. Okay, and then whatever you have the second one here should come to here, X. Okay, and then what's the third one here? It has to be here in Y. And the least significant bit has to be Z. You understand what I'm saying? That means if for any rate, for example, again, this map is for this order. When W is the most significant, next one is X, next one is Y, next one is Z is the least significant. Okay? For any reason, if I want to change it, if I want to make it X, Y, Z, W, if I want to make it this way, you have to change this map accordingly. You understand what I'm saying? So the most significant bit has to come here. Next one. I will try to quiz in anything. I will try to follow this order. Okay, but you need, because if you see an example online, I don't know how they made it in Zybooks, you need to know order here is important. Whatever you have here has to come. Okay. Any questions? Okay. Now, so let's now, so this is W prime, X prime, Y prime, Z prime. So which mean term is this one? I already explained before how can you do it, okay? Every prime, you have to replace it by 0. If there is no prime, you have to make it 1. So if you follow this one, this is actually 0, 0, 0, which is mean term 0, okay? Same thing here, 0, 0, 0, 1. So this is mean term 1. If you look at this one, 0, 0, 1, 0, okay? So if you follow this way, you will see a surprise here. It's not a, or something you need to pay attention to. If you look at the order here, this is mean term 0, mean term 1, and then look, 2 is here, 3 is here. You see the switch? Okay? So 0, 1, 2, and 3, or 0, 1, 3, and 2. Okay? So always here in these two columns, we switch. Okay? So here, 0, 1, 2, and 3, 4, 5, 6, and 7. Is that clear? Okay. This is because to follow this map, because if you want to make it in a different way, if you make M2 and you make this one M3, you are not gonna find one area for Y, one area for X. It will be somehow different. But anyway, so and then also you can see the last two rows are switched. So you switch here, we switch these two, and also we switch these two. That means if you see here, this is M7. M8 is here, not here. So the last two rows we switch them. So M8, 9, 11, 10. You can see. So we actually switch these two and these two columns, and we switch these two rows. Is that okay, guys? Any questions? Okay. Why this is important? Because of the next slide here. Okay. So if I give you a function like this one, similar to what we did before, number one, you have to map the truth table to the map. This is number one. Number two, you have to make groups similar to what we did before. You have to make groups. Okay. So let's start. How can you map it here? That's easy. You can look at for the ones here. So we have one here in M1, M6, M7, M8, M11, M14. So this location M1, 6, 7, 8, 11, 14. So I'm gonna put ones. That's it. Similar to what we did before. Okay? So you already know the map. So you need to know where are the midterms here. Midterms are the location of ones. In this location, you have to put ones here. That's very easy. Is that okay? Same thing, if I give you a function this way, similar to what we did before, these are the location of ones. So you have to go to M2, M3, M6, to here 2, 3, 6. M10 is here, M15 is here. Okay, so these are the location of ones. The other locations for sure are zeros. So if you write it or you don't write it, it doesn't matter. So it's zeros. Okay, we'll have something else. Usually you have 0 or 1, okay? But I'm gonna explain, sometimes we have 0 or 1, sometimes we have X. Don't care, okay? But this is very special case and we'll talk about it, okay? But usually either 0 or 1. Same thing like what I explained before, I need to know neighbors, okay? Who are the neighbors? Similar, exactly same thing I explained before, but the difference is, in case of 3 variables, every square or every cell had 3 neighbors. Now, every cell has 4 neighbors. So every cell has 4 neighbors. And I will use the same definition I used before for neighbors. 2 squares are neighbors if there is only change in one variable. Okay? So the variables, for example, if I come back to here, you can these two are neighbors or not. Okay, if you look at the variables here, W prime, X prime, X. So X is different. Y is the same, Z is the same. So there is only one difference in one variable. So yes, they are neighbors. Okay. If you look at this one and this one here, okay, W prime, X prime, X. So X is different. That's number one. Y, this one has Y and Y. Okay, they are the same, but Z also is different. So there are 2 differences here in X and Z. So these are not neighbors. Okay. So anyway, so again, every cell has 4 neighbors. So let's look, for example, for this cell, who are the neighbors of M2? Always, the neighbors are vertical and horizontal neighbors, as you see here. Okay. So let's start, I think let's start with another case because, yeah, for example, if you look at M7 here, okay? So M7 has 4 neighbors, vertical and horizontal. So here, these are vertical and also you have horizontal neighbors. Same thing if you look at M13, it has neighbors, 4 neighbors, vertical and horizontal. Every cell has 4 neighbors, okay? Every cell here in the map has 4. It's not at least 4, no, 4. Every cell has 4, okay? Anyway, but here, if you look at this one here, so this is one neighbor, and actually this one also a neighbor. So you can think about this map, it's like you roll it, okay? So when you roll this map this way, so actually the cell here become neighbor to the cell here. This is the same thing we did in 3 variable, okay? On top of that, I will add something we didn't have in 3 variable, which is also you can rule it this way as well. That means, as you see here in this figure, so any cell here should have a neighbor on the other side. Because you think about it, you can rule it this way. This one has a neighbor here, okay? So based on that, this cell here, M2 has one neighbor here, one neighbor here. It also has one neighbor this way, and also this way. You get what I'm saying? So you can rule it this way and this way here. Okay. Let's see more examples. For this one, so these are neighbors here, and the number 4 is this one. Okay. If you look at this one, these are neighbors, and number 4 is this one. Okay. I already made a definition. What neighbor means? They should change in one variable. Okay. So if you look at the variable, you will see here what I'm saying. What I'm saying, I'm claiming this one is neighbor to this one. That's my claim. Okay, you can check now. You can see here W prime, X prime, and Y. So Y is different, only Y. So there is only change in one variable. Okay, what about it? Also, I claim this one is a neighbor to this one. Okay, let's see. W prime and W. So W is different. There is one difference now. X prime, Y, Z prime. So there is only difference in W prime and W. Okay, so yes, they are neighbors. Anyway, same thing. If you look at this one, they have a neighbor this way, and neighbor this way. You can think about the map. You can rule the map this way, or you can rule it this way. So this also neighbors. Okay. If you look at here, if you take this one here, the direct vertical and horizontal cells neighbors are neighbors. Okay, as you see here, but also I can end this one as well. Okay. Now, so similar to what we did before. Number 1, if you have a function, number 1, you have to map the function to the key member. Okay. Number 2, you have to do groups. You have to group, similar to what we did before. And similar to what we did before, you have to minimize the number of groups. Every group is gonna contribute by one term in the function. That's number 1. Number 2, you have to maximize the size of the groups, because the bigger the groups, the less variables you are gonna have in the terms. Same thing here as well. But the difference is here you can make groups of only one cell similar to 3 variable. You can make it 2 similar to 3 variable. You can make it 4 similar to 3 variables. Same thing. So these are, so it can be 1, 2, or 4. This is the new stuff. You can make it actually 8. I told you 3 variable, you can make it 8, but it's very extreme case. That means I'm going to take the whole map as one group. This happens when f is equal to 1. Okay, this is very extreme case for sure. But anyway, but here you can make group of 8, or you can make for sure 16. Here is the extreme case. This one can happen when all of them are ones. So I can make it only one group, and in this case, f is equal to 1. Anyway, so that means whatever the input is, f is 1 all the time. Okay, but anyway, this is just a very extreme case. It's not a realistic case. Most of the time, we're going to make group of 1, group of 2, group of 4, and also group of 8. Is that okay? Let's see here. If you make group of 1, Like for example, in this case, this one doesn't have any neighbors, so I don't have any other choice than just taking this one alone. Okay. Every group of one should have 4 variables here. 4 variables. Okay. If I want to convert with 3 variables, in case of 3 variables, if it is group of 1, you have 3 variables, not 4 for sure. Okay. Here we have 4. Okay. How can you find it? How can you find this one? Okay, you have one of the 2 options. If you already know this one here, that's easy. If the one is here, so I'm gonna take this term. If the one is here, I'm gonna take this term here. Or you can, and I prefer the second approach, you can see where this one is located in the areas, in the 4 areas. For example, look here, guys. Okay, so this one, let's start with W. This is in the area of W or W prime, because this is W and this is W prime. That's why here I'm going to select W. So again, if you make group only 1, if it's only 1, you already know you have to find 4 variables. You have to find the 4 variables. Okay. So this is for W. If you look at X, okay, X is here. So this one actually is in the area of X. That's why I'm going to take X here. Okay. If you look at Y, yeah, this one is the area of Y. So I'm going to take Y here. Okay. And also, if you look at Z, it is in the area of Z because this is the area of Z, this one. Okay, guys. So again, conclusion. If you can make a group if only 1 cell, and in this case, this term is going to have 4 variables. Okay. Min term. So this is min term, no simplification. It's like min terms. Okay. So now you can group 2 neighbors. 2 neighbors, you can group them together. And if you do that, if you group 2 neighbors together, you are going to have a term that have 3 variables. Okay. So if it is only one cell or one square, so you're going to have 4 variables in this term. If you can group 2 neighbors, and you already know what I mean by neighbors, so these 2 ones here are neighbors. So in this case, the term is going to have 3 variables. Is that okay? Okay. How can you find the 3 variables here? Okay. So that means how many variables you have in total? I have 4. That means I have to omit 1. I have to cancel 1. Okay. So which one I have to cancel? You will find that this group is not located in one variable or the prime of this variable. Okay. So you will see right now. So for example, if you look at this one here, okay, look at W. So this is the area of W. So this one is, okay, so sorry, let's start with W. So this is the area of W. So it's very, very clear. These 2 ones are located in the area of W prime. So I'm going to take W prime. Very easy. Okay. If you look at X, it's very clear. This is the area of X. This group is located, the whole group is in the area of X. So I'm going to take X. Okay. If you look at Y, yeah, so this group is located in Y. So I'm going to take Y. Okay. But if you look at Z, this is Z, and this is Z prime. So this group is not located in Z area or Z prime area, half and half. So that means this is a variable I have to cancel. So you have to remove this variable. Okay. In other words, let me see. This is one way to think about it. There is another way. If you look at the intersection of the area W prime with the area of X with the area of Y, you will get these 2. Can you show me? I will show you. Look here. What is W prime? So this is W prime here. What is X? Here is X. So what is the intersection so far? The intersection so far is this part. Okay. Now add Y. This is Y is here. So now the intersection is these 2. You got it? So again, this is something you can check after you get the term and you want to make sure if it's correct or not. You can just see if the intersection of these areas, if your group, whether your group is 2 or 1 or 4 or 8, it's still applicable. If your group is the intersection of these areas, so you are correct. Okay. Now let's see another example here. In this example here, this one and this one are neighbors, so I can take them together. okay? Because you rule, don't forget, you rule it this way. They are neighbors, okay? So that means I need three variables. I have to find three variables. Again, how can you find the three variables? Okay, let's look one by one. W, is this group in W or W prime? No, the answer is no, because have one part of the group is W, one part of the group is W prime. So I have to cancel, I have to remove W. W is not gonna be here, okay? If you look at X, so it's very clear, this group is in X prime, so I'm gonna take X prime, okay? This group is in Y, so I'm gonna take Y. This group is in Z, because this is Z, okay? So I'm getting X prime, Y, Z. Any questions? Again, this is exactly similar to what we did in three variables. Okay, we have another example here. Again, I can make one group here. If you look at W, I have to cancel W because this one here is W, this one is W prime. Okay, so W is not going to be here. You already know if it is a group of two, you should have three variables here. If you look at X, yes, this one is located in X, this one is located in Z, this one is located in Y prime, the area of Y prime. That's what I did. Same thing if you look at these two here, same thing. So this group is located in, let's look in W prime, okay? Because this is the area of W prime. So I'm gonna take W prime. What about X? Yeah, this one is located in the area of X prime. What about Y? Okay, wait a second. So here, part of it in Y and part of Y prime. That means I have to cancel Y, okay? So, and then, what about Z? It is in Z prime. Okay, and again, if you do again what I did before, if you do the intersection, you will find the intersection of these three areas is going to give you this group. Any questions? Okay, any question before I move to group of 4? So let me make it easy. If you have group of one, the term is going to have 4 variables. Okay, if you have group of 2, your term, the term should have 3 variables. If you have group of 4, the term has to have two variables. Okay. If you have group of 8, it should have only 1 variable. 8. In case if you take 8 as well, it's going to be only 1 variable. Okay. So anyway, so let's go to group of 4. So these are neighbors. Group of 4 this way. Okay. Okay. How can you? That means I have to cancel. You have 4 variables. So now I know because it is group of 4, the term should have 2 variables. That means I have to cancel 2 variables. Okay, 2 variables I have to remove. Okay, which ones? Again, similar to what I did. So for example, if you look at W, so part of it in W and another part in W prime. So I have to cancel W. Okay, if you look at X, yeah, this one is located in X. So I'm gonna take X as you see it. I'm gonna take X. Okay, let's look at Y. No, I'm gonna cancel Y because part of it in Y, another part in Y prime. So I can't take it. Okay, if you look at X, sorry, if you look at Z, yes, this one is in Z. So I'm gonna take X and Z. And again, you can think again, that means this area here, this area should be the intersection of X and Z. Okay, is that true? Yes, because this is Z and this is X. The intersection of these 2 areas is gonna give you this group. Any questions? Make sense? Okay. Let's see other examples for 4, group of 4. Yeah, you know, this also neighbors. This one are neighbors. Again, you need to think about this map rule. You need to rule this map. So if you rule this map, this will be neighbors. Okay, this way and also this way. These are group of 4. How can you locate it? Again, similar to what I explained, they are in the area of X. And they are in the area of X and also in the area of Z prime, X and Z prime. Okay. Let's look at this one first. This here I can group this one again because you can. This map is rolled this way. Okay. So these 2 are actually neighbors to these two. Okay. So I can make it as only one group. Okay. Now, and this maybe is a new little bit new part. So actually, these ones here are also neighbors. Why? Because actually, the way I can explain it is, if this is the map, you think it's ruled this way. We agree on that, right? Okay. Also, it can be ruled this way. We agree on that. It can be ruled this way. That means whatever I have here is going to be neighbor to this ones. And also whatever I have here is neighbor to this one. But also, all these ones are going to be, I don't know how can you make it, but it's going to be something like this one. Okay, so these ones here, like they are going to be also, you can rule them again. Anyway, so here, this ones here also is, you can make it one group. Okay. Okay, but in this case, what term I can have here, similar to what I explained. This, let's look at W. So here we have some of them are in W, some of them are in W prime, so I have to cancel W. Let's look at X. Yeah, the whole group is in X prime, so I'm going to take X. Let's look at Y. So this part in Y and this part in Y prime, so I'm going to cancel Y. Okay. And now, if you look at Z, this is all of them are in the area of Z prime, so I'm going to take Z prime. And if you don't believe me, try to make the intersection between the area of X prime and the area of Z prime, you will get this one. Okay, so let's see. This is the area of Z prime. This is Z prime. Okay. Okay. And this is the area of X prime. Oops. X prime is here. So if you see the intersection between these two areas, we will find they are here. Any questions? Very important thing, and we have too many examples. You will see them in the example. So if you have a situation like this one, you can make a group this way. You can take this one and this one as one group, and you take this one and this one as one group. For sure, this is not the most simplified way because you created two groups. That means two terms. Okay, it would be much better if I can merge all of them together in a bigger group. Okay, to have only one term. It's a simplified function. And if you another examples for groups of four. Okay, so these fours are neighbors, and I can get this one. Okay, these fours are neighbors, as you see here. Okay, this Y and Z. So if you see this group is located in Y, also it is located in Z. But if you look at W, half of it, W, half in W prime. If you look at X, part of it in X, part of it in X prime. Okay. Anyway, also if you see the intersection between Y and Z, you will find this one. So this is Y, and this is Z. The intersection is actually this part here. Okay. Now I'm going to move to group of 8. So group of 8, this will give you only one variable. Okay. So let's start. This for sure. I can take this 8 together. This 8 can be together. Okay. And in this case, I need only one variable. So this is going to occupy. Listen to me. Every area. How many areas here do I have here? I have one area for W, one area for W prime. I have one area for X prime. I have one area for Y, one area for Y prime. I have one area for Z and Z prime. Every area here is itself. That means the result I'm gonna get is one of these areas. Okay, so that means the 8 one should be one of these areas. Okay, so that's why you can see here this one in W, this one in W prime. So this one is in W prime. If you wanna check the other ones, it's not. You will see here. If you look at X, so here part in X prime. So I have to cancel X. Okay, but you don't need to waste too much time this way because you need to only find one area. Okay, but anyway, it is this part in Y, this Y in Y prime. Okay, if you look at Z, this part in Z, this part in Z prime. Okay, same thing if you look at here, this is the area of Z, so this is the area of Z prime. So this one should be Z prime. Okay, so this 4 and 4 should be, again, you can think it's ruled this way. Okay, so this should be neighbors because you can rule it this way. Same thing, you can take this 8 together and the result is Z. Okay, you know, as I told you here, these are the options I have, either W or W prime. That means, look here, the 4 can be here to make W. This is one option. The second option, the 4 can be here to make W prime. This one second option for W and W prime. If you look at X, the 4 can be here to make X, or the 4 can be here and here to make X prime. because it has to be one of these, okay? In case of A. Y, either the 4 is here or here, okay, for Y, or the 4 are here for Y prime, okay? For Z, either I can take this one as 4 for Z, or I can take here this 4 and this 4 together to make Z prime. Okay, so I already listed all of them. Okay, so this is the area of Z. This is the area of X prime here. So now, so let me summarize what I said. If you have only one group of one cell, you should have a term that has 4 variables. If you have a group of 2, the term should have 3 variables. Okay. If you have group of 4, the term should have 2 variables. If you have group of 8, the term should have only 1 variable. Okay. So similar to what we did in case of 3 variables, exactly same thing. We have to you have to minimize the number of groups and maximize the size of the groups. Simply because when you make every group, it's going to make one term. So when you minimize the number of groups, I can minimize the number of terms. That's number 1. Number 2, when I maximize the size of groups, I can minimize the number of variables in each term. Okay, that's exactly. So again, similar in order to do simplification, similar to what we did in 3 variable. Number 1 rule number 1: you have to cover all ones. You have to cover all ones. Okay, and then you have to maximize groups, and you have to minimize the number of groups, maximize the size of groups, and then you can calculate the function. So I have yeah, so for example, here I give you here, yeah. So for example, if you have here, so what I did here, for example, if you have an example, something like that, okay, guys? Here I decided to make 3 groups. I took these 4 together for one group, okay? These 4 together, one group, and these 4 together, one group, okay? I decided to make it this way, okay? So again, similar to what I explained before, as long as you cover all ones, you are gonna have correct function, okay? But this correct function, it may not be the most simplified, okay? So in this case, I will get 3 terms, okay? For every group, 1 term, as you see here. But actually, there is a better way this one is correct function, but it's not the most simplified, okay? I can simplify this one more. How can you simplify this one more? If you look carefully here, I can take these 4 together with this 4 to make only one group of 8. Is that right? Same thing here. I can take this 4 here with this 4 here, as you see here in this figure here. So I can take 4 and 4 to make one group. So let me use some colors here. So if you, yeah, so this one here with this one, okay? To make one group of 8, one group of 8. And then also here, I can take this 4 here and this 4 here, okay, to make a second group of 8. In this case, I can make the function this way. Okay, if you compare this function, it's very clear this one is more simplified than the other one. Okay, so nothing is new here. It's just similar to what I explained before. When you make groups, you have to find the maximum. You have to minimize the number of groups. You have to maximize the size of groups. Okay, to calculate the most simplified function. Okay. Again, similar to what I explained before, you can see this one overlaps. So this one overlaps between 2 groups. This one is shared between the 2 groups, which is totally fine. Okay. Anyway, so I have too many examples here, maybe 12 examples or something like that. I have too many examples, 13 examples to understand how can we do this. And also, I will go through this example, but again, my advice to you, you have you don't look at the solution, okay? So you have to solve it by yourself. Because if you just look at the solution, you will think, yes, it's easy, just take this one, that's easy. But when I give it to you to do it by yourself, it may be more difficult. You understand what I'm saying? So don't just read the solution, try to solve it by yourself. You have too many examples here, you have Zybox, so you have a lot of examples to practice, okay? So let's start with the first example here we have. If I have the ones this way, okay? Let's start with this one. Do you have, for this one, do you have any better choice here, this one here, other than making group of one? Do you have any other option? The answer is no. This one doesn't have any neighbors. There are no neighbors. So I cannot make bigger groups than that. So this one has to be only one alone. Okay. Same thing, this one. What is the best choice for this one? Just take it with its neighbor this way. Okay. Yeah, it's very clear. I have 4 here together. I can take these 4 together. Some students may make one redundant group by taking these 2. You don't need you already covered this one. So why you cover them again? These 2, this one and this one already covered in groups. If you make another group, you are going to have a redundant term here. Okay. Any questions? Okay. Let's see another example here. With this example here. First of all, you need to think about bigger groups. Okay, so it's very clear here. Okay, it's very clear that I have 8 groups this way. So yeah, that's very great. I can cover these 8 together in one group. Okay. Now, what is left here? Okay, still I need to cover this one. Still I need to cover this one. Still I need to cover this one. Okay. Okay. Let's look at the second one here. What is the best option for this one? I have 2 options for this one. Either I take it alone or I take it with this one neighbor. Okay, no, it's better to take it with the neighbor. Okay, this is the 2 options I have. So this is a better option. That means this one is shared between groups. It's totally fine. Okay. So now let's look at this one and this one here. Okay. Here I have multiple choices. I can take, let's use a different color. Here, I can take this one alone and this one alone. Okay. No, but that's a bad idea. Let's do, because they are neighbors, so I can take them together. Makes sense? They are neighbor. I can take them together. No, this is still bad idea. Why? Because now I created group of 2, but I can create group of 4. Why? How can you create a group of 4? Because this is 1, 2, 3, 4. I can make a group of 4. So this is the best option for me. By this way, I'm going to have 3 terms, the most simplified terms. Any questions? Let's have more examples. Yeah. So if you look at this, I wish let's try to solve it by ourselves. I think this will be much better strategy. So let's, for example, I'm gonna put it here. Don't look at the solution, okay? And then I will put here 2, and then 1 here, 1 here, and then put here 1 and 1. Okay, so don't look at this one. Okay. Let's look at this one here, guys. Okay. First of all, let's look at group of 8. Okay, group of 8, which is the biggest thing I can do. It's very obvious here. I have one group of 8 here. Make sense? Yeah. So now I cover this 8 just in one hit. One hit, I got 4. Okay, good. So it's like we're playing a game. Okay, so now we need to cover these ones. Okay, let's look at these ones. If you look at this one here, I have options. I can take, for example, if I take these 2, I can take them individually this way, but that's a bad option. I have a better option. I can merge them together this way. This is still bad option because I have a better option, which is simply I can take these together this way. Group of 4. Okay, don't say, okay, I can take this one as well and make group of 6. It's not allowed to make group of 6. Okay, we make group of 1, group of 2, group of 4, group of 8. Okay, so this is the best I can do for this one. Okay. And okay, so we have 2 left here. What should I do for these 2? Because I need to cover everybody. So still we have 2 here. I did not cover yet these 2. Okay, again, they are neighbors. I can take them together. No, I have a better idea. I can take 4. This one. Make sense? Can you do better than that? I don't think so. If you can, let me know. I don't think so. Anyway, so let's see how I solved it here. Yes, I took here group of 4, I took group of 2, but here I took these 2 together and I got a function. This function is correct as long as you cover all ones, but it is not the most simplified function. Why it's not the most simplified? Because it would be better if I can take these 4 together. Because if you take these 4 together, still the number of terms will be the same, but if I take these 2 here this way, this term is going to have 3 variables. But if I merge it 4 this way, this term is going to have 2 variables instead of 3. This is some simplification I can do. And that's what I did here. So if you compare this function to this function, you will find the 3 terms. The only difference is here. This one is WY, this one is WXY. Why? Because this is group of 2. When I took group of 2 this way, group of 2, but here it's better to take group of 4. Any questions? Again, here let's look at this one here. It's already solved, but I can do it. So try to remember the location of once here. Okay. So I think okay, I think I remember, but let's see. So here I'm gonna put 1, 1, 1, 1, 1, 1, 1. I just want to solve it by myself. Okay, because sometimes when I explain what to solve it this way, it will be easy. That's why I'm asking you, when you study this topic, you need to solve it by yourself. First of all, I can hit 8 in one group. Okay, I'm very happy. Yeah, you already took 8 in one group. Is that okay? Now let's look at these 3. What options do you have? For sure, I can take these 2 together, and then I can take these 2 together. Now I cover all of them. Okay, is that the most simplified? The answer is no. This is not the most simplified. Okay? Or someone can take this one with this one, and this one with this one, and this one with this one. Again, it's not the most simplified. Why? Simply because I can, let's use a different color here. I can take these 2 with these 2 to make group of 4. So instead of making group of 2, now I'm making group of 4. Same thing here. So how can I cover this one? This one here. I can cover it alone, but this is not the best way to do it. So I can cover this one alone. I can cover it with the neighbor here, group of 2. I can cover it. I can cover it with I can cover a group of 2 with this one here, but this is not the most simplified. Okay, so what I can do here is which is a better option. I can simply take these 2 together and these 2 together, make group of 4. Okay, by this way, I have 3 groups. Every group has 4. Okay, and that's what I did here. So I take all of these together, and then here you have group. This one here, group of 4, and then in order to cover the last one here, I'm gonna put it in group of 4. Any questions? Sorry, this one 8, group of 8, and then group of 4, 2 group. That's why if you look here, if it is only one variable, that means group of 8, 2, group of 4, and 4. Any questions? Yeah, sure.
So a group is only redundant if all of the terms have already been used.
Yeah, already covered. Okay, so if already all the ones are already covered, this is a very good point. I'm sure it will confuse the student, because if you look here, someone will be confused. Okay, I will because this one is not covered yet. Okay? But if I take it with this one's, but this one already covered. This one already covered. We cover it again. It's okay to cover it again, as long as this one does not cover it at all. Okay? This is a big difference between when I can say it's redundant, when it is redundant. For example, if I want to cover these two together in one group, this is redundant because these two together are already in one group. It's redundant. But if I have a one here that's not in any groups, and in order to put this one, this one will make a new group anyway. Okay, because it's not covered, it's gonna make a new group. But it will be better if I can take it with one that's already covered. That's okay. You understand the difference between these? I'm sure this is a very important point. I'm sure some of you will be confused about it. Okay. So again, it's okay to cover someone's again, it's okay, as long as in the new group, you have at least one that was not covered at all. Okay. When it becomes redundant, when you create a group where all the ones in this group already covered, so this is redundant. For example, if I want to take this one as a group, this is redundant because this one already covers all of them. But if there is only one here in this group that's not covered, it's okay. This is the difference between when overlap is okay and when I can say subset or when it becomes redundant. Okay. Anyway, so let's have more examples. If you look, maybe this is an easy example. And similar to what I explained in case of three variables, sometimes there is no one unique solution for the most simplified. Sometimes the most simplified is going to be there are multiple solutions, all of them are equal, equal regarding simplification. All of them are mostly simplified. So most simplified, sometimes it does not mean it's a unique solution. No, we can have multiple solutions, all of them are most simplified. So let's look at this case here. I'm giving you this function. Here I'm asking you to simplify this one, okay? So the first thing here you need to do, if I give you this function this way, the first thing you have to do, you have to map. I have to map this one to here. How can you map? Maybe this is the most important thing in this example, because simplification looks easy. So how I can map this one to me here? You already know when this one is 3, 3 means how many, so that means it has to be 2 ones. This one group of 2, this one group of 2, this one group of 2. You got what I'm saying? Because that means 2, 2, 2, 2 means 8. But here I have 6, not 8, because overlap, there is some overlap. Okay, that's okay. So if you look at this one here, in the intersection of W prime, this is W prime, and X prime, this is X prime here. Okay, for sure I have another X prime here, but it's not gonna interact with the first one here. X prime, and then Y prime. So if you see the intersection between all of them, it's gonna give you, so this term is gonna give you these 2 ones here. Make sense? Again, guys, I want to help you to protect you. I want to protect you from making mistakes. Okay? Again, I'm saying as long as this term has 3 variables, so it has the intersection has to be 2 squares. When you do it and you find it's 4 squares, something is wrong. If you do it and you find it's 1 square, something is wrong. It has to be 2 squares. Same thing for this one as well. So let's look at this one here. W prime, X prime. So X prime, that means this one and this one, this is X prime. Y does that mean this part here is Y. And Z prime. Z prime, that means this part and this part, but for sure, I'm going to take this one here. So if you look at the intersection between all of them, you will find these 2 here. So the intersection will be this one here and this one. So because of this term, I'm going to put here 1 and 1. Yeah. So here, this term is going to contribute this to these 2. This term actually is going to contribute to this one and this one. Okay. Okay, let's look at the next one here. And so I'm gonna leave them to you. You will find maybe I think someone here is gonna be covered more than one here. That's okay because of the overlap. So here, for example, W prime is this area, and X is this area. So now the intersection so far is this part. Intersection so far W prime X, Y because of Y. So the intersection is this part. I think I did something. Let's do it again. W prime is this area here, X is going to be this area, this area here, X, okay, and then Y, yeah. So here the intersection so far is this one with Y. Yeah, because this one is actually what confused me. I'm still thinking, yeah, this one should be two ones. No, this is 4 variables, so it has to be only one square. So every time I try to overlap them. No, I can't get 2. Okay, because this one is 4 variable, it has to be only 1. Okay. So anyway, so if you see the intersection, you'll find it here, only 1. Okay. Same thing for this one. Any question, guys? So anyway, very important to practice. If I give you function this way, how can you map it? So okay, once I map it, let's simplify it. How can you simplify it here? Okay, let's look at let's start, for example, with this one. This one I can take it alone, or I can take it with neighbor. For sure, it's much better to take it with neighbor. These are only 2 options I have. Okay. Now, for this one here, I can take it alone, or I can take it with neighbor. I can take it with the neighbor here. Okay. Okay, what about this one here? This one here, I can take it with this one. Now I created a redundant group. So now I created a redundant group. Why? Simply because what happened here is this one group. Okay, I want to take this one, so I can take it with one big one that's not covered, or I can take it with one that's already covered. Okay. So I think it would, and both of us are same, so it's better to have this group that's not covered. But if I keep it this way, this is redundant. I created a redundant group. Why? Because this one here already in one group, and this one already in one group. You see the redundancy. So the redundancy here, this one is already in a group. Okay, this one already in group. So I cover them again in one redundant group. So in other words, if I remove this one, it's gonna hurt me? No, I still covered all of them, or at least this one so far. Okay? Same thing here. I can make one group this way. I don't need to make this group, it's gonna become redundant. I don't need. So you can see here the best options I can have is just have 3 groups. 3 groups, every group has 2 ones this way. Okay? Then I don't want to keep repeating, but I think it's easy for you to get this one. If you want me to say it again, let me know. So here it's very easy. Once you have this group, you can make the equation. If you want me to do it, let me know. Okay. Any question? Let's have one more example here. So example number 6 here. Yeah, so here I have only 4 ones, so I can take these 2 together. I can take these 2 together. Someone can add one group here, this way, the green one. So this green one is redundant. So if you look at the solution here, I got here, and the solution I got here, you can find this term is this term here, but I got a redundant term. You got what I'm saying? I got a redundant term because this group is useless. If I remove it, it's not going to hurt me because already I covered all ones. I don't need it. Okay, so it's going to have a redundant. Anyway, any questions? Okay, let's have here. And the good thing what can we see in this example? I'm going to have 2 solutions, and the 2 solutions are correct. They are different. Okay, and these 2 solutions are the most simplified, and both of them are correct. When something like this happens, I will tell you when something like this can happen. Okay. So for example here, I can take these 4 together. I can take these 4 together. Okay. This is one of the groups. It should be these 4 together. And this group is actually essential group. You remember when I explained before, we have prime group and we have prime group. That means this is the maximum I can do. That's the meaning of prime group. Okay. So this is prime group. I cannot make it more, I can't make it bigger than that because it's 4, after 4, 8. Can I make it 8? No, I can't. So this is a prime group. But also, this is an essential group. Why this one is essential group? Because if you look at this one here, yeah, so no, sorry, so here, if I make this one another group here, so essential group means, okay, this is the only possible case you can cover a one. So for example, if you look at this one here, is there any other groups that can cover this one here? Yes, there is one group here which is 2, right? But 4 is better than 2. But anyway, but this one should be essential group because if you look here, if you look at this one here, what is the best case for this one? Do you have any? So the best case for this one is to take this 4. Is there any other 4 I can take for this one? No. That's why if you look here for any most simplified, you will find almost you need to take this group. You don't have any other option. Okay, any other option equivalent option. Equivalent means group 4. Sometimes, as you will see here in this example, I just want to show you why we have different solutions. The reason we have different solutions because sometimes we have 2 options. These 2 options are equal. This 4, this 4. That's why in one solution I can take this 4, in another solution I can take this 4. Okay, and I will take, but here in this case, this one should be essential because the only way for this one, and same thing for this one by the way, but for this two has another option. I can take this 4 together anyway, okay? But I can take this 4 together if you want. But anyway, so anyway, for this one and this one, the only way to put them in group of 4 is this one. That's why you will find it in the 2 solution. Even this is the 3rd solution, by the way. I have 3 solutions. All of them are the same level. All of them have 4 terms, as you see here. Every term has two variables, so I have 3 solutions that are equivalent. What you can notice here, this group is essential. That's why you can see in the 4 solutions. Okay. Okay, so what is not essential, for example, if you look at these 2 here, if you look at these 2, let's use a different color. These two. So for these 2, I have different options. That's why I'm just explaining why sometimes I have different solutions because I have multiple options. All of them give me the same level of simplification. So for example, if you look at this 4 here, okay, this 4 I can make it like this one 4 this way, or I can make it group this way. So now I have 2 groups. I have 2 groups that can cover these 2, and they have the same level of simplification. So here in this solution, I decided to take this 4, but in this solution, I decided to take this 4. This is the only difference between these 2 solutions. Okay, so to cover this 2, I have here one option with 4, another option with 4. So here in this solution, I took this 4. In this solution, I took this 4. Let's see, in this solution, I took this 4. Okay. Okay. So let's see, for example, one of also the essential groups is actually this one here. So if you look at this one has only one case for the most simplified. This one I have 2 options. Either I take it alone or I take 4 for this one. Okay. Do you have any other group with 4? No, only one group of 4. So this is essential. So if you look at one solution, you will find this group. And that's what I did here. So here, I found this group is here. I found this group is here. Even when I tried to solve it in a different way, I also found this group here because this one here has only one group. Okay. But this is different from these 2 here when I had 2 options. Okay. Anyway, what else? What else is, if you look at this one here, to cover this one here, okay? This is not essential. Why? Simply because I can take this one, I can make 4 this way, or I can make 4 this way. This is 4 and this is 4. So to cover this one, I can take this one or take this one, okay? That's why you will find in this solution here, I decided to take this 4, okay? Here also I decided to take this 4, But if you look at the solution, I decided to take this 4. Okay? Again, the beauty of this example, or the most important thing in this example to learn, we're not gonna have a quiz today, so don't worry about the quiz. The quiz I'm gonna make it on Thursday. It will be, the quiz will cover 3 variables. It's gonna be simplification for 3, not 4. And test 1 will be 4 variables. Okay? Anyway, so what I'm saying here, guys, is what is good about this example? What's good about this example? Number one, you can learn. We may have multiple solutions. We may have multiple solutions for the most simplified function. That's number one. Number two, you can learn some groups are essential. Even if you have different solutions, some groups there should be there because I don't have other options like this group here and also this group here. Okay. But some groups I have, so here in order to cover this one here, I can make 4 this way, or I can make 4 this way. This is 4 and this is 4. That's why this created 2 different groups. Okay, anyway. Let's have an example number 8. It's almost also somehow complicated. So here, same thing I'm explaining here what we mean by. So let's see, for example, this example here. Number 1, let's look at this one here. Okay, let's look at this one here, guys. What is the best case for this one? To take these 4 together, right? This one here. This one. Is there any other option for this one? So in order to cover this one, I'm gonna take it with this one, this one, this one, and this one. Rule of 4. Okay. So this is essential. So whatever, even if you have different solution, you will find this one. Because I can't have a group with 4 that has this one. I can't. So it's only one option. That's why this one is essential. Okay. But look at, for example, these 2, I can take 4 this way. Okay. This one also essential, right? Why? You know, if I have 1 here, these 2 would not be essential because I can make 4 this way or I can make 4 this way. But in this case, this one should be essential. So it has to be this one. Anyway, so I can also make to cover this one. So again, let's my advice to you, if you have a complicated situation like this one, you have to start with the ones that you have only one option or one group for them. Like for example, here I can take this one as one group. So okay, this one. Now let's think about this 2, how I can cover this 2. Okay, for sure it's better to make group of 4 this one. So now I finish this part. So who is left? Still I have this one here. Okay. So what is the best for this one? This one I can take it alone. I can take it with the neighbor here to make group of 2, or I can make group of 4 here. It would be much better to make group of 4. You see the options I have for this one? It can be alone, it can be 2, it can be 4. Right? Also it can be 2 here, 2, this one and this one. No, 4 is better, so I'm going to take 4. Okay. So after you take 4, so what is left here to cover all of them? Only this one is left. This one here is left. Again, this one I can take it alone. I can take it alone. I can take it with this neighbor or this neighbor or this neighbor, but still group of 2. Or it's going to be much better if I can take this one in a new group. I'm sure the part will confuse you is this group already covered. So this one already covered, 2 covered. This one covered. This one already covered, right? That's okay. It's okay to introduce a new group as long as at least there is one that's not covered. It's not redundant. Okay? So this is not redundant because I introduced them, because this one is going to create a new term anyway, right? This one is going to create a new term. And this one is not covered. But the other ones are covered. It's okay. It's not a redundant. Okay? So this is the best way I can do this way because I can make it out of 4. Anyway. I can solve it in a different way, but again, you can see here, comparing to the solution I had here, you can see this one here is essential, and also these ones are essential. What is not essential is actually this one here. Look, This one here. It's not essential. Why? Because this one I can take group of 4 this way, or also I can make group of 4 this way. Okay? This is 4, this is 4. That's why in this solution, I made it this way. But if I look at the previous solution, I made it this way. Don't bother yourself with that. Your focus has to be, number one, you need to cover all ones. Number two, you need to minimize the number of groups. Number three, you need to maximize the size of processing. Okay? But I'm just explaining to you why it happens that we have different solutions. Okay. Also, what happened here when the last one here I tried to cover this one here, I had one option group of 4 this way. I have another option. I can take this one with this 4 here. See what? And that's what I did here. So what I did here to cover this one, I have two options. Either I take this 4 together, or I can take this 4 together. This is the same level of simplification. This is 4, this is 4. Okay. Anyway, let's have more examples. Here, if you have these ones here, first of all, it's very clear. I can take this 4. I can't make 8, right? I cannot make group of 8. So let's focus on 4. So now if I take this 4 together, I will cover this one here. Okay. Now let's look at so who else I have to cover? I have to cover this one, this one, this one, this one, this one. Okay. So let's for example, if I make another, I can make another 4 this way. The best I can do, I cannot make 8. There is no way to make 8 here. So 4 is the best thing I can do. So here, this is 4, this is another 4. Okay, what is left? This one here, this one here. Okay, let's look at this one. What I can do for this one. Okay, what I can do for this one is, for sure, I can take it alone, bad idea. I can take it with neighbor, bad idea. I can take it with one neighbor, bad idea. I can take it with 4, this one. As long as the group, if all the ones in a group already covered, except only one at least, so this is not redundant. Okay? Same thing, the last one here, to cover the last one here, the best thing I can do, for sure I can take it alone, bad idea. I can take it with neighbor, 2, group of 2, bad idea. Group of 2, bad idea. Why it's bad? Because I can make it group of 4. 4 is better than 2. Any questions? Again, guys, listen to me. If you just look at the solution, I'm quite sure 100% you are not going to do well in the quiz and also the test. You need just to take it. You need to take this one, yeah, and to try to solve it by yourself. Okay. Don't look at the solution. Let's look, for example, here. This one will be easy. Number 10 here. I can take these 4 together. This has only one solution. There is no other solution. Okay? You understand what I'm saying? Sometimes you have only one unique solution. Sometimes you may have more than one solution. In this case, it's very clear we don't have options. Okay? If you want a group of 4, I can take this 4 together, and also I can take this 4 together this way. So I'm gonna have two terms, and because group of 4, every term has two variables. This one. Okay? Let's look at this complicated example this way. Okay, so here, I wish if I can take it. Okay, I will try. Okay, so I will try to put it. Try to remember it easily. So here you have your 1, 1. Okay, so we have here 1, 1, 1, 1, 1, 1. Okay, what else? 3 ones, actually 1, 3 ones. I think that's it. Okay. Let's think how can you solve it. Okay, I want to solve it with you. Okay, let's think. Again, you can find the best thing. There is no way to make group of 8. So now you have to focus on 4. The best thing I can do is 4. Okay, so it's very clear I can make this 4 together. This number 1. Make sense? Okay. And then also I can see in order to cover this one here, I can also take the best thing I can do group of 4. Okay, so I can take this 4 together. So now I have 2 4s. Make sense? Okay, now let's look at this one here. What I can do for this one. For sure you have bad options. Okay. The bad option I have, I can take it alone, which is a bad option. I can take it with this neighbor, which is a bad option. I can take this one with this neighbor. I have bad option because I can make it group of 4. How can you make group of 4? I can make this one here and this one. Make sense? So who is left? Who is left is actually these two here together. Okay, I'm sure many of you would, yeah, take it 4 this way. Okay, this is a different color. Okay, this is not a good option. You can do better than that. You can make it this way. No. What else I can do? This is not good. You can make it group of 4. How? I can take this way. So now I can, how many groups I have now? 1, 2, 3, 4. I can have 4 groups. Each one is 4. 4 groups, each one is 4. Okay. Any questions? Yes. That's a very good question. Let's see. Who knows? Maybe you are right. Can I eliminate the purple one? What do you think? Anyone can tell me? Yeah, it's redundant, right? You're right. Okay, it's redundant. Why? Because if I remove it, it's gonna hurt me? No, it's not gonna hurt me. Why, yes, I can remove it, right? Can I remove this orange one here? Can I remove it? No, if you remove it, you are gonna have 2 which are not covered. Yes. Okay. Yeah, you're right. So I can eliminate. I think so. Maybe I need to correct this one here and make it 4, but this is not the most simplified one. Oh no, maybe here I did a different solution here. No, yeah, what I did here, this solution is a second solution, but it's more simplified this one. So there is one group right here I can eliminate. Can you see me here which one I can eliminate? I think. Which one?
There's another one that you took.
Yes. I think
The top left one.
this one is essential. Oh, no, sorry. This is a different, I'm sorry. This is a different problem because I forget this one here. Okay, I forget this one. So this one was like an extra problem, different problem. You understand what I'm saying? So this problem is not, I forgot this one here. Okay. You got what I'm saying? So yeah, this one is correct. Given what we, but that's okay. At least we did practice on one year. Okay. Let's have, for example, something like this one. We can put it here again and we can think about it. So if you put in 1, 1, 1, 1, and then here 1, 1, 1, 1, and 1, 1. Okay, if I make it this way, okay. Hopefully I did it correctly. Okay. I think I did it correctly. Again, can you make group of 8? No, I don't think we can make group of 8, but it looks like the best thing I can do here, group of 4. So what if I can take these 4 together? Okay, and now to cover these two, okay. So I can take these 4 together this way. If I do that, I don't need to add another group this way. I don't need to add it because I already covered this one using only 2 groups. You got what I'm saying? So what I'm saying is that I can think this way. I can add one here, this way, and then after that I will see, okay, how I can cover this one. I can take, so this way there is one extra I need to remove. You got what I'm saying? So my initial thinking was how can we take this 4? Okay, but I found it may be better to take this 4. Okay. Now let's look at these 2 here. What is the best thing I can do for these 2? Okay, so I think I can make only one group of 2, right? So that's what I did. Anyway, so last example before we leave. Okay, this one here. So as you see here, if you look at let's do it quickly here. So I'm gonna take here, we have 4 here, 1, 2, 3, 4. And then here we have 1 here. then we have here, three here, 1, 2, 3. Let's think about it together, okay? So first of all, I can't make group of 8, so the best thing I can take these 4 together, so these are 4, okay? Now, let's look at this. Can I make something if I want to cover this one? Is there any other options than this one here? I don't think so. Okay, so just give me 1 second, I'm done. So also I can take these 2 together. Can I do something better? I don't think so. Also, I can cover this one with this one. So how many groups you have right now? 1, 2, 3, 4 groups. I think that's the solution I have here. Anyway, I try to, when you go home, try to think about it. But you need to keep in mind, there may be multiple solutions, but as long as all the different solutions have the same level of simplification, a number of terms, a number of variable in terms, so all of them are valid solutions. Anyway, so yeah, so again, on Thursdays there will be a quiz. It's going to be 3 variables. I will ask you to do simplification. In test 1, I will give you 4 variables. Okay. Thanks.